innovative approach in calculus we will proceed upon Taylor and Maclaurin polynomial approximation. Taylor and Maclaurin polynomial approximation for the multivariable case. So this is what we are pursuing. We have successfully we have drawn the multivariable polynomial case for the dual multivariable x and y. Okay, for single multivariable case, single variable case, what is the Taylor series or Maclaurin series? If I have any algebraic function fx, if I have any algebraic function fx, okay, if I have any algebraic function fx, okay, what is fx? this is this is fx. Okay, so this is fx algebraic function. What is your algebraic function? Algebraic function is hidden inside this fruit. Okay, what is your algebraic function in single variable case? Algebraic function is hidden inside this fruit. What is inside this fruit? Then it is sin x plus log x square plus log square x, so many things. Okay, this is your algebraic function. Yes, this is my algebraic function. What are else in the algebraic function? It's very big. I cannot disclose it. This is what I keep on saying. So I cannot disclose it. This is an algebraic function. If this is your algebraic function, very nice. Thank you. Okay, now I want to copy your algebraic function. You cannot copy this. I can copy it. I can approximate it. And scenario is, then how you can approximate my algebraic function when I'm not going to tell you what is my algebraic function. So if I okay, okay, this is the actual algebraic function and this is the copied one. Okay, so this is the copied one algebraic function. This is the copied one algebraic function. The way it is like that only. So this algebraic function need to be copied in other algebraic function. So this is one fruit. This is from the same family other fruit. Okay. Now idea is, can I copy this as this? This is not same. There is a difference, but still they are very. They are from same species. They are from same species. Not only it comes in a mango family, but it is also from the exactly same class it comes from. Whatever the class this has, same class this is exactly same, but still they are not same. Little bit difference is there. If little bit difference is there, but it's all right. So my question is arising that if I have an algebraic function, can I copy it in other algebraic function? But this person who is carrying, I am carrying this algebraic function, and algebraic function is pretty complex, and I am not going to disclose what is the algebraic function. If I am not going to disclose what is the algebraic function, then how someone can replicate it? No, he would ask some question, and I have to reply. And based upon those reply, someone would now replicate this to another kind of entity. That is the scenario. If that is the case, then what is the question? Now someone is asking, if I am going for Lorentz Taylor series, then someone is asking, what is your value at any point x equal to x0? X0 can be 1, 2, 3, 4, any numeric value. As per the Maclaurin series, what is the value of your function when x equal to 0? 0. Let's go with Maclaurin. When x equal to 0. Now I am holding this algebraic function and I set here and there x equal to 0 everywhere. And whatever the output came, I replied, this is the output. What is dy by dx, dfxy by dx, first derivative value when x equal to 0? What is second derivative value when x equal to 0? What is third derivative value when x equal to 0? What is nth derivative value when x equal to 0? Now, if I get all the reply, I can reconstruct it as now fx equal to some algebraic equation. Now I am reconstructing. So this is the actual algebraic function, and this is what I am reconstructing. Okay. Now this would, the way it is look like same, that much it will be. It is, after all, it is approximation. So if I consider this as fx, new fx is coming into the picture, which the value of this fx will be received from this algebraic equation based upon the derivative when x equal to 0, all the order of derivative. Now, if that is the scenario, then how someone can reconstruct fx? Now, someone would write fx equal to, then what is the value of fx when x equal to 0? Plus, plus, what is the value of dfx by dx? Dfx by dx when x equal to 0. I can say dfx by dx when x equal to 0 into x, plus d2fx by dx square into x square into 1 by factorial of 2, plus d3fx by dx cube into x to the power 3 into 1 by factorial of 3, plus dnfx by dxn x to the power n into 1 by factorial of n. This is called Maclaurin series or Taylor series. Okay, when I am getting the value when x equal to 0, then it is Maclaurin series, and when x equal to any x0, any x value, then it is Taylor series. In Taylor series, wherever I am saying dfx by dx, there I have to say dfx by dx at x equal to x0 somewhere, and x square x to the power 3 x minus x to the power n will be replaced by x minus x0 to the power 1, 2, 3, 4, n. This is Taylor series. Now we saw multivariable case. In multivariable case, now I am replacing x. I am replacing x with x plus y. I am replacing x. The way, now we saw the way we calculated how someone came to fx equal to the new fx. This is the original fx and this is duplicate fx. Duplicate fx equal to original fx when x equal to 0, plus original dfx by dx when x equal to 0 into x. How someone came to this solution? Someone came to this solution because now I am now some other person who is copying my algebraic equation. How he deduced this formula? He deduced this formula because for him, now he took the ideal case of series of polynomial equation, that is fx equal to a0 plus a1x plus a2x square plus a3x to the power n plus an x to the power n. Okay. In that case, first he saw what is value of fx when x equal to 0, that is a0. Okay. What is value of fx dfx by dx when x equal to 0? Then first differentiation means a0 gone, only a1 would remain, other are gone when x equal to 0. So a1 equal to dfx by dx, d2fx by dx square, first two gone, and next is 2 into a2 plus all in x equal to 0, all gone, a2 equal to 1 by 2 d2fx by dx. Now d3fx by dx cube, first 3 gone, 3 into 2 into a3, that's it, plus all are gone, x equal to 0, a3 equal to 1 by factorial of 3 d3fx by dx cube. Now whatever a1, a0, a1, a2, a3 we are receiving, we are substituting there and we are getting the Maclaurin series, Taylor series. Please watch previous video, must. Okay, now for the multivariable case, what we have to replace is multivariable case comes when we are talking about here independent component is x. Independent component is x. In multivariable case, independent component is x and y, two multivariables. In that case, we are considering a single independent component, that is xy plane. Now, if it is xy plane, single independent variable is x, then everywhere there is x. If it is single independent component xy plane, then wherever I have put x, it will be replaced by xy plane. Okay. So what is the ideal polynomial case of the multivariable case? fxy. Earlier it was xy. Now ideal multivariable case is fxy equal to a0 into xy plane to the power 0 plus a1 into xy plane plus a2 into xy plane to the power 2 plus a3 xy plane to the power 3 plus an xy plane to the power n. Now idea is, what is xy plane? Idea is, what is xy plane? X, if I say only x line, then everywhere it is x. If I say xy plane, then what I can replace with x and y? That is under question mark. Then we saw that the equation, if this is xy plane, okay, this is x-axis, this is y-axis, this is z-axis, that is fxy. If there is a surface that is lying on xy plane, if there is surface that is lying on xy plane, and this is y-axis, and this is z x-axis and y-axis, this is origin, this is origin. If this is origin, keeping y-axis constant, if I tilt it, then at any point, this is x-axis, at any point x, what is the height it took? The height is nothing but whatever the slope is into x. What is height at this point where x equal to x1? Whatever the slope is into x1, that is the height. So height is z, then z equal to slope into x. Slope is nothing but dz by dx. Okay, right now it is z by x also would work. But if it is surface is not a flat line, then dz by dx we need to take. We will see it in product rule. It will eat up some time. Now same thing, if I see they keep x-axis constant and lift y-axis, then at any moment y, what is z? That is dz by dy into y. At any moment y1, what is z? Dz by dy into y1. Now if I lift both, first if I lift like this, then at any point x1 there is some height. Okay. Now I go this direction. Now this point is x1 y1 both. Okay. Now I lift, now I keep x-axis constant and I lift y-axis. Now at any point x1 y1, how much it lifted? If I go back again, then it had lifted at any point x1 y1, any point x1 y1, since I have not changed y-axis, it had lifted dz by dx into x1, dz by dx into x1. Now keeping the x-axis constant, if I lift again, then how much it is? So whatever lift is there, it is now adding to it. If you see, more lift is going on. Or if I keep x constant completely and lift only y, then lift at any point x1 y1 is dz by dy into y1, dz by dx into x1. Now first this and then this. The net height is the dz by dx into x1 plus dz by dy into y1, because it is adding up, because I am keeping one constant at one axis constant in both times. So the net height that is increasing at any point x1 y1, that z is, when first it was kept at xy plane, the net z at any point x1 y1 is dz by dx into x1 plus dz by dy into y1. Or other way I can say dz by dx, this differentiation calculated at point x equal to x1 into x. I'm trying to find the surface equation. Okay, surface equation nothing but equation for the z only. Surface equation. Surface equation. This what is surface equation? Surface equation is z equal to 0 because it is lying at xy plane. What is surface equation where it is at height k parallel to xy plane? Z equal to k. What is surface equation here? Z or fxy equal to dz by dx into x. Okay, dz by dx calculated at any point x equal to x1. Then surface equation at point x equal to x1 is dz by dx calculated at x equal to x1 into x, dz by dx into x. Okay, at any point y1 dz by dy calculated y equal to y1 into y, dz by dy calculated y equal to y1 into y, like this and this. At any point x comma y, what is the height? First dz by dx into x plus then dz by dy into y. The equation of this surface, this equation of this this surface, equation of this surface is z equal to dz by dx calculated at x equal to x1 x into x plus dz by dy calculated at y equal to y1 into y, dz by dx into x plus dz by dy into y. That is the equation of the surface. That is the height at any point x equal to x1 and y equal to y1. At point x1, y1, dz by dx, x equal to x1 into x plus dz by dy, x equal to x1, y equal dz by dy, y equal to y1 into y. Now we know that first order derivative fxy, if I am trying to copy a function, if I am trying to copy, okay, I have I have earlier earlier I had single variable, earlier I had single variable algebraic function as this. This is a single variable variable algebraic function. Okay, what about dual variative algebraic function? Okay, so we will have dual variable algebraic function. Okay, I have this dual variative algebraic function. Consider this is fxy. This this is this is fxy. This is fxy and this is I have to replicate. I have to replicate this is fxy. I have to replicate this fxy into new fxy. That is the concept. So this fxy equation is very complex. Now, what information I need from this fxy so that I can copy and I can create new fxy as the multivariable polynomial approximation. So that is the idea. Okay. Now, now we know. Now we know. Now, so what someone would try? Someone actually, when he's trying to replicate, what formula he kind of invented is first he took a well-behaved single variable polynomial equation, that is fx equal to a0 plus a1x plus a2x square plus a3x to the power 3 plus an x to the power n. Okay, if that is the case, then he saw a0 is nothing but if this fx someone is calculating when x equal to 0, then it becomes fx, it becomes a0. dy dfxy by dx, when x equal to 0, then a1 becomes dy by dx. dfx d2fxy by dx square, when x equal to 0, then a2 becomes 1 by 2 d2fxy by dx square. This is what was seen. And this is how just then someone just replaced a0 with fx when x equal to 0, a1 dfxy by dx when x equal to 0, a2 d2fxy by dx square into 1 by 2 when x equal to 0. So this just keep on replacing and someone can build the copy of the algebraic equation. What about multivariable case? Multivariable case, if I have fxy, if I have if I have fxy, if I have fxy, then fxy, what how someone can replicate in all. Now, one idea is he has to question the person who is carrying the fxy for the all order derivative in multivariable case. If that is the case, then first he is what he should order. Then in his hand, what is the ready-made approximation is available for the first order derivative. First order derivative is we have a0. What is the polynomial equation? That is fxy equal to a0 into a1 xy plane plus a2 xy plane whole square. I am keeping one independent component as xy plane. Okay, because if earlier if I say I have a if I have a earlier case, if I have x axis, then there is a curve that is dependent upon x axis, that is called fxy. Now similarly, if I have a xy plane and there is a surface, then surface is now is fxy dependent upon xy plane. I'm not saying x axis and y axis. The surface is dependent upon xy plane. So if that is the case in 3D fxy, all x term, what was there in fx, all x term we are replacing with xy plane. Now fxy fx equal to a0 plus a1 x plus a2 x square plus a3 x to the power 3 plus an x to the power n, where a1 a2 a3, where an can be replaced with dn fx by dxn into 1 by n factorial. This is what we saw. If that is the case, then well-behaved polynomial equation fxy is a0 plus a1 xy plane plus a2 xy plane whole square plus an xy plane to the power n. X I replaced with xy plane because in 3D there is a surface is dependent upon xy plane. In 2D there is a curve dependent upon x-axis. Similar thing. But now question is coming that xy plane I cannot take. I have to resolve it into x and y. What value I should replace that it should resolve in x and y? What is single order? What is single order polynomial approximation? Single order polynomial approximation for the Taylor series and Maclaurin series is fx equal to, if I a0 for time being, if I don't take, fx equal to dy by dx dfxy by dx into x, dy by dx into x. But already I know that fxy equal to dz by dx into x plus dz by dy into y. This I know. As per the basic nature of algebra, the z value at any point is dz by dx calculated at that point into x plus dz by dy calculated at that point, that is x1 y1 into y. That is the formula of z at point x and y. Okay, that is fxy equal to dz by dx into x plus dz by dy into y. If it is calculated at point x1, then actual formula should be dz by dx x minus x1 plus dz by dy y minus y1. For completeness I am saying this. So if we are calculating the dz by dx at any point x equal to x1 and y equal to y1, then actual approximation would be, formula of the surface would be z equal to dz by dx when x equal to x1, x minus x1 plus dz by dy when y equal to y1, y minus y1. Now let's keep x1 y1 as 0. Then z equal to dz by dx calculated at x equal to 0 into x plus dz by dy at y equal to 0 into y. This much I know. Whereas in single dimension it is dy by dx, dfxy by dx into x. In dual independent component, fxy equal to dfxy by dx into x plus dfxy by dy into y. Now how they are related to each other? Okay. Now let's try replacing xy plane with x plus y. Xy plane with x plus y. If that is the case, then fxy equal to a0 plus a1 and in bracket it is x plus y. That was xy plane earlier, x plus y, plus d plus a2 x plus y whole square, plus a and x plus y to the power n. I replaced xy plane with x plus y. At the end, I have to come to x plus y. Let's try again. Seeing first order derivative. dfxy, dfxy, that is the first order derivative. dfxy by dx equal to a1 plus 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 a1 dy by dx. Since they are independent to each other, 0. Rest 0 when x equal to 0, y equal to 0. So a1 equal to dfxy by dx, dfxy by dy equal to a1 dx by dy, that is 0, plus a1 plus all are 0 when x is 0, y is 0. So a1 equal to dfxy by dy. Now I can replace a1 there. Now the fxy equal to a0. A0 is nothing but when fxy, the value of fxy when x equal to 0, y equal to 0. In that sense, fxy equal to a0. fxy a0 is fxy when x equal to 0, y is equal to 0, because all are 0. So fxy equal to fxy when x equal to 0, y equal to 0, plus a1x plus a2y. Now a1 is replaced by dfxy by dx into x plus dfxy by dy into y. It is exactly same as what we have deduced. fxy equal to dfxy by dx into x plus dfxy by dy into y. So this proves that I can happily replace all the xy plane with the x plus y. Someone can try other thing also. Replacing xy plane with x into y, x by y, x minus y, whatever comes to someone's mind. X plus y works. Means in this case I can replace xy plane with x plus y. If that is the case, then let's see the double order derivative. d2fxy by dx square. Then a0, a1 gone. Now there it is a2x plus y whole square. Then a2x square, a2x square becomes 2a2 plus double derivative means all are 0 when x equal to 0, y equal to 0. So a2 equal to 1 by 2 d2fxy by dx square. Similarly, d2fxy by dy square, then again it will be 2a2 in y term, other will be 0. So a2 equal to 1 by 2 d2fxy by dy square. Now there is another one more term, that is a2 into 2xy, because x plus y whole square it was there. a2 into 2xy. a2 into 2xy, if I first differentiate dfxy by dxy by dx, it becomes a2 into 2y. Again dfxy by dy, then it becomes a2 into 2. a2 into 2. So a2 into 2 equal to dfxy by dx into dfxy by dy. Now the third term was a2x plus y whole square. Now that becomes a2x square plus a2 into 2xy plus a2y square. Now a2x square, a2 can be replaced with d2fxy by dx square into 1 by factorial of 2. Now a2 into 2xy, a2 into 2 can be replaced by dfxy by dx into dfxy by dy into x into y, plus d2fxy by dy square into 1 by factorial of 2 into y square. Now someone can settle a3 x plus y to the power 3 with the triple differentiation. This is the polynomial expansion, polynomial approximation for the multivariable case when x plus y. Now let's try with the three-dimensional independent component. Right now we have two-dimensional independent components, two-dimensional independent component x and y. What about three-dimensional independent component x, y, z? Then it is also called density function. Density function, density function means I have independent component at x, y, z. This is x-axis, this is y-axis, this is z-axis. This is exact x, y, z density function. Density function means if I have a triple independent component x, y, z at any point inside this, volume, any point inside this volume, what at any point x comma y comma z, when it is centered at the origin at any point x comma y comma z, what is density? Inside, if I cut it outside, it is skin that is hard, and then there is a pulp, and inside it there only seed are there. Everywhere density is different. So density is high chance it is function over x, y, z. So fxy function over x and y lead to height. Function over x, y, z lead to density. It is also called density function. If that is the scenario, then what would be the Taylor series and Maclaurin series for the density function? Triple independent variable. In that case, if I go with triple independent variable, then what would be the equation for the density? Now, same thing we would apply equation for the density. Now, first I have to see x and density plane, y and density plane, z and density plane. Earlier we took x and z plane, y and z plane. Now I have to take x and density plane along x-axis. How much is the density? Whatever the density is in x density plane, I can draw like a x-axis and y-axis. There is no problem in that. Along y-axis, what is the density along y-axis? I can draw as y as a horizontal line and density as vertical line plane. For z, what is the density along z-axis? So x density plane, y density plane, and z density plane. So in x density plane, what is the density at any point? D density by dx into x. Same thing, the way we are doing. What about, because in single dimension, if you see, same thing we try. What is the equation? What is the equation of this line? This line. Equation of this line is the slope of this. What is the height of this line at any point x1? Whatever the slope is multiplied by the x1, that is the height at the x1. So since the slope at every moment it is same, it's a straight line, y equal to dy by dx into x. This is what we say. But dy by dx need to be calculated at x equal to x1. That equation would be y equal to dy by dx at x equal to x1, x minus x1. Okay. So that is the scenario. If we are calculating dy by dx at x equal to 0, then y equal to dy by dx at x equal to 0 into x. Okay, so that is the scenario. So for triple independent component, I have to find the density at any point x equal to x1 is density equal to d density, but the density is d density by dx when x equal to x1 into x. Similarly, density along the y-axis is d density by dy into y, d density by dz into z. Now, all together, if I start varying the way I showed, that here I vary in x-axis and then y-axis. Now, if it is triple dimension, then first I vary along the x density plane, then vary in y density plane, vary z density plane. Altogether, how much is the density when point is x1 comma y1 comma z1? Then it is summation of all three. D density by dx at x equal to x1 into x plus d density by dy when y equal to y1 into y plus d density by dz when z equal to z1 into z. If that is the case, then at any point x1, y1, z1, that is the net density. I believe better equation will be d density by dx at x equal to x1, x minus x1, plus d density by dy at y equal to y1 into y minus y1, plus d density by dz when z equal to z1, z minus z1. If I calculate this at origin, then dz by dx calculated at x equal to 0 into x, dz by dy into y, dz by dy plus dz by dz into z, where all three dz by dx, dy, dz calculated at origin. So if that is the case, then it will be similar to what we had replaced x with xy plane. Now we will replace with xyz cube. So the well-behaved polynomial equation is fxyz equal to a0 where a0 is the value of equal to a0 plus a1 xyz cube plus a2 xyz cube whole square plus an xyz cube to the power n. This is the well-behaved polynomial equation. If I set x equal to now for the now if I set kind of what about the first order derivative? First order derivative here is dfxy dfx dfxyz. For the first order derivative is dfxyz by dx into x plus dfxy by dy into y plus dfxy by dz into z. Okay, this is the result. I know this is the result. How I can achieve this result? When I have a0 plus a1 xyz cube plus xyz cube plus a2 xyz cube whole square plus a3 xyz whole cube plus an xyz to the power n. How this first order derivative I can get like this? Then now I can replace xyz cube with x plus y plus z. Same way what we did with x plus y. X plus y plus z. If I replace with this x plus y plus z, then first order derivative, if I go dfxy by, now it becomes a0 plus a1 and in braces x plus y plus z plus a2 x plus y plus z whole square plus a3 x plus y plus z whole cube plus an x plus y plus z to the power n. dfxyz by dx equal to a1 when x, y, z all are 0, 0, 0. All becomes 0. a1 equal to dfxy by dfxyz by dz. Again a1 equal to where I have a1x plus a1y plus a1z. Again a1 equal to dfxyz by dy. Again a1 equal to dfxyz by dz. If that is the case, now a1 I can replace there. Now fxyz equal to a0 when xyz equal to 0 plus a0 means a0 is nothing but when value of fxyz when xyz equal to 0 plus a1 I can replace now here with dfxyz by dfxyz by dx into x plus dfxyz by dy into y plus dfxyz by dz into z. This is first order. Second order a2 and x plus y plus z whole square that I have to find. Now so a2 x plus y plus z whole square is x plus y in braces plus z whole square. X plus y plus z whole square equal to x plus y in braces plus z whole square. That is x plus y whole square plus z whole square plus 2z x plus y. That is x square plus y square plus 2xy plus z square plus 2zx plus 2zy. That is x square plus y square plus z square plus 2xy plus 2xz plus 2yz. Now a2 into all those stuff. Now d2fx by dx square is a2. All are gone when xyz equal to 0. d2fxyz by dy equal to a2. All are gone. I mean a2 by 2. a2 into 2. d2fxy by dfxyz d2fxyz by dx square is 2a2. dfxyz by 2 d2fxyz by dy square is 2a2. d2fxyz by dz square is 2a2. Now x square plus y square plus z square a2 a2 a2. Now a2 I can replace with 1 by factorial of 2 x plus 1 by factorial of 2 d2fxyz by dx square into x square plus 1 by factorial of 2 d2fxyz by dy square into y square plus 1 by factorial of 2 d2fxyz by dz square into z square. What is remaining there is 2xy plus 2yz plus 2zx. Now dfxyz by dx into dfxyz by dy. If I do, it will become 2 into a2. All other are 0. So 2 into a2 equal to dfxy by dx into dfxyz by dy. Now another is 2x into z. dfxyz yz by dx into dfxyz by dz, that is equal to 2 into a2 again. All are 0. dfxy by dz by dy into dfxy by dz by into dz is 2 into a2 again. So second order derivative is replaced by 1 by factorial of 2 d2 fxyz by dx square into x square plus 1 by factorial of 2 into d2 fxyz by dy square into y square plus 1 by factorial of 2 d2 fxyz by dz square into z square plus dfxyz by dx into dfxz by dy into x into y plus dfxyz by dy into dfxz by dz into y into z plus dfxz by dx into dfxz by dz into x into z. Now second order derivative settled. Third is a3x plus yz to the power 3. Now same way triple differentiation someone can try, and this is the polynomial approximation of the triple independent component x, y, z. Now someone can try x, y, z plus alpha plus beta plus gamma up to 100 up to n, but this is our proof. This proof is not available in any of the book anywhere. Whatever is available, no one can go beyond the two level independent variable. But this proof, anyone can go to any level. Please do support us. Plus 91 is the India country code 9483160610. Plus 91 is the India country code 9483160610. Please do support us, it helps. So we will proceed in other other approach, innovative approach that we have achieved, so that we will see.